Right. So, um, right. To find the distance traveled when given a velocity time graph, it's the area under the graph. That's how you find the distance traveled. So in this case, it's kind of simple. This is just a rectangle. So my length would actually be 4, and my breadth or width would be 3. So to find the area, 4 by 3 is 12. Distance travel is 12 meters, right? But let's just assume it was actually, yes, 12 meters. But it's not always that simple. If you get a graph like this, that's marvelous. Good for you. But I'm telling you, it's not usually this simple. Sometimes you might have to break up the graph into triangles. You might get a trapezium. Actually, the trapezium is a very common shape. You might get a graph instead of a horizontal line. Like the entire graph is just a straight, it's just a horizontal line. You might get one looking like this. And they ask you to find the distance traveled throughout the entire journey. Let me just extend this graph a little bit. Let's just pretend this is touching, and we would say this is 6 seconds. We want you to find the distance traveled over this entire journey. Hold on, let me look at the chart. So does that only apply to uniform shapes or any graph areas? You can use it. It applies to all velocity time graphs. If you get a velocity time graph and they ask you for distance travel, it's always the area under the graph. It doesn't matter what that graph looks like. The distance is always the area under the graph. Only distance time. Distance time. What are you talking about? This is velocity time. The area under the velocity time graph is distance traveled. Let me know if you're confused about that. So. Okay. If they give you a graph like this, and they ask me for the distance traveled throughout my entire journey, meaning from the origin to the 6-second mark, so this entire thing here, this is a trapezium. So you can use the formula for trapezium, the area of a trapezium, or if you don't feel comfortable doing that, you could actually break it up into a rectangle and a triangle. Let's just say this is 4 seconds. The area of my rectangle would still be 4 by 3, 12. The area of a triangle is base by height on 2, or you might say a half base by height. My base from 4 to 6 seconds, so that's 2. My height from 0 to 3, so my height is 3. And therefore, to find the area of this triangle here, a half base by height, so a half by 3, well, by 2 by 3. So that's 2 by 3 is 6, and 6 divided by 2 is 3. So if the area for this triangle is 3 meters, well, 3 meters squared, and then the area of this rectangle is 12, 12 plus 3 is 15, so the total distance traveled is 15 meters. That's it. Do you understand that? Understand? Would you like me to go over that again? I need you to let me know. You have one person saying they understand. What happened to the rest? If you didn't understand anything, just let me know.
Which one you're doing? Which one you're doing?
Do you mean which one?
Which part you're doing? Which?
Which shape? I'm finding the area for.
I wasn't really paying attention. I was eating food.
Okay.
Wait, what were you doing?
Finding the area under this graph.
Oh, the last one? Oh,
I should actually add some things here. I should put like etc. because this is really not the only way to find. So for the people who are actually, paying attention, do you understand? Titania, Makario, do you understand what I just did?
Miss, could you go over it, please?
Oh, this is sometimes ask questions. What I like to do, ask questions. Okay, now. So let's say this is the graph they gave you, a velocity time graph, and they ask you to find distance traveled. So you see the minute you see this velocity time graph, and they ask you to find distance traveled, that's the area under the graph. So let's just say they gave you this graph, and they ask you to find the distance traveled. So that's the area under the graph. Let me highlight the area now, and here. So this whole thing here. It's not supposed to pass this, right? But this whole area I need to find. You might know the formula for the area of a trapezium, which is a half the sum of the parallel sides by the perpendicular height. Let me just write that in case you didn't know. The sum of, so let me just put sum of parallel sides multiplied by the perpendicular height. Just me writing it symbolically, right? If you didn't know that, that's cool. You didn't have to know that, because I can actually break this up into two different shapes. Let's just say it's supposed to be a straight line, right? Straight vertical line. I can actually break up a trapezium into a triangle. Let me just highlight the triangle in blue. A triangle. Is that blue? Is that anyways? Hopefully you can see the triangle.
Miss, it's half the parallel sides times the perpendicular height.
Yeah, sum of the parallel sides. Okay, so before I split it up into a triangle and a rectangle, let me just do this one using the formula for the trapezium. So you can see, in case you want to use that from now on, by all means, go ahead, right? So it's a half sum of the parallel sides. Parallel sides that I'm referring to would be this. Can you see that? I don't think I can use this. Let's just pretend that's straight. And this. Those are my parallel sides. Notice they are parallel, they will never meet. I could extend this all the way down, so it will never meet, right? That's how you see parallel sides. Cool. So let's just say at this point here, it's only 4 seconds. So this length, the length of this from 0 to 4 would be 4. And the length of this side here would be from 0 to 6. So it's 6. Let me use a different color. So the length is 4 because we're going from 0 to 4, 0 seconds to 4 seconds. And this length is from 0 to 6. So that will give me 6. Right? Do you understand how I got the 4 and 6? Okay. So that's my parallel sides. I want the sum of the parallel sides. So that would be 4 plus 6 multiplied by the perpendicular height. This is my perpendicular height. Notice it is perpendicular. So I could just draw a triangle, right angle right there. That's the perpendicular height. And it would give me 3. From 0 to 3. That's 3. Multiplied by the perpendicular height. BODMAS, BOMDAS, whatever you used in primary school when you were doing this whole thing, algebra thing. First, we work the brackets. So 4 plus 6 is 10. And then we say that's multiplying by a half. So a half by 10 by 3. A half by 10, that's 5. 5 by 3 is 15. So my answer would be 15 meters for the distance traveled. Or you might say 10 by 3 is 30, 30 by a half is 50. You still get the 15, right? So you could have done that, use this formula for the trapezium, or if you didn't know that, or you're not comfortable with this formula, you can actually break this shape up into a triangle and a rectangle. Find the area separately and then add them. That's good too. You're not gonna get marks deducted for that. Wait, do you understand this? How I got 15?
Yes, miss.
So I said instead of using this, I could actually find the area of the triangle, which is here. I just highlight this in green. And then the area of the rectangle. And whatever values I get, I could just add them. This is the rectangle. Can't really see that. But like, hopefully you get what I'm saying. This is the rectangle. A triangle on a rectangle. Find the areas, add them. So we're using this. We know that the area of a rectangle is length by breadth, or you might say width, whatever, right? Same thing. My length for this rectangle, 0 to 4, so that's 4. The width is from 0 to 3, so that's 3. And then for the area of my rectangle would be 3 by 4. Well, triangle now. The area of a triangle is a half base by height. Or you might say base by height divided by 2. The base from 4 to 6, that would give me 2. So my base is 2. The height is from here to here. So I'm just highlight this. The height, perpendicular height, is 3. From 0 to 3. So the area of my triangle is a half base by height. So a half by the base, which is 2. By the height, which is 3. 3 by 2 is 6. 6 by a half, or you might say 6 divided by 2, same thing, is 3. And therefore, if I want to find the total distance covered from 0 to 6, I have to add both these areas. So 12 plus 3 would give me 50. So the answer is the same. Whichever approach you decide to take, the answer should be the same. The total distance traveled would be 50 meters. Do you understand that now?
Yes,
3
miss.
times. Wait, when was that? Yes, easy. Didn't even call my name Sadness and I'm paying attention. I'm not saying that name. Yes.
Oh, yes, miss.
Okay, cool. Nice. So the different ways to estimate this area, you could use the triangles. You could use triangles, so I use a triangle. Trapezium, you could use the formula for the trapezium. Counting squares, that's not very accurate, but I mean, I would actually take this out tonight because people actually use this to estimate the area, but it's not a very accurate method, you know? You could also use the rectangle like we did here. And then sometimes you would be required to find the integral. Remember when we were doing applications of integration, we said area under a curve has a specific formula. It was A. So the integral of y dx between A and B, oh, that's an A, that's a B. B is my upper limit, A is my lower limit. Y is the function that they gave me. When you have a curve and you need to find the area, that's what we would be applying. We're not ready for that yet. That's coming soon, coming soon. Count the square and let's see if it's 15. I can't count the squares here. To do that, I would need a scale. Like, you know how you might have a scale beside y is 2. Okay. No, sarcasm. Anyways.
Miss,
Right.
so basically when you're finding the area under the graph for that illustration that you have, you separate it into a square and a triangle, and after you do 2 separate calculations, one for the square and one for the triangle.
This is a rectangle in this case.
The rectangle and the triangle.
So if they want the total distance, which is the part and the green part, then you will have to add the both areas that you got. And that's why you said 12.
And that will be the final area, Miss?
Yeah.
Okay, Miss, I understand.
Yeah. And the answer would be 15 meters. So instead of putting meters squared, which is the standard unit for area, they want distance. So the unit is meters in this case. Okay.
But since it's area, we don't say meter square.
Well, I mean, technically the unit for area is meter squared, right? So it should be meter squared, but that's not what they're asking us for, and that's not what we're trying to find. Yes, we use the area, but what we really want is distance traveled. So the unit that we would put is meters instead of the meter squared. We just use the area to find the distance. You understand that?
Yes, Miss.
I'm clearing this now, right? 3, 2, 1. Let's practice this now. The motion of a bird traveling in a straight line is tracked for 60 seconds. So from 0 to 60, well, it's not starting from 0, but the end time is 60 seconds. This information is displayed in the velocity time graph below. Please note that they don't always give you a graph. Sometimes they do. And you need to, like I said, extract data from the graph to find what you want. Sometimes they would give you information and you are required to draw your own graph and then do all your calculations. So that's why it's important to understand what you're doing. Okay, so they asked me to calculate the acceleration of the bird at 20 seconds. Before you do any of this, right, see the kinematics questions and you see graphs on them, underline what type of graph they're talking about. Velocity time graph. What do you know about velocity time graphs? That's why I had key features. It's okay. That's why I had key features, right? So whenever you're doing kinematics and they start talking about graphs, just underline what type of graph they're talking about. When you know the type of graph, go back to the key features. What are the key things that I should know for this type of graph? Then you continue. So just note that, right? A, calculate the acceleration of the bird at 20 seconds. Acceleration and velocity time graphs. How is acceleration related to a velocity time graph? Well, I would say acceleration is the gradient of a velocity time graph. So since they want acceleration, and this is a velocity time graph, I need to find the gradient. How would I do that? That's what we need to find out. Calculate the acceleration of the bird at 20 seconds. So where's 20 seconds? Looking at this, maybe it's around here. I don't know, 20 seconds. Let's just say this is 20 seconds. Acceleration, we don't want to find the gradient. Even though they did not give me a value for the velocity when the time is 20 seconds, so they didn't label 20 seconds and then give me a velocity here, right? So you cannot assume 20 is here and then velocity is 3. You don't do that, right? You apply your knowledge of gradients. This, even though the line is it's a downward slope. This is still a straight line. What do you know about straight lines and their gradients? Their gradients is constant. So it does not matter which 2 points I choose on this line, it doesn't matter which 2 points, right? Whichever 2 points I choose, the gradient will be constant for this entire line. Therefore, I can use 2 points, any 2 points given on this line to find the gradient, because the gradient would be the same. Do you understand that? You said yes?
Yes.
Okay, nice. So can you find me the acceleration and let me know your answer?
Yeah, the answer is minus a third. Or you could write it as a decimal, minus 0.333, like to 3 significant figures, or you can leave it as minus a third. If you didn't get that, please let me know. Yes, it would be a recurring. So let me do it. How, bro? We're not there yet. I said, even though they did not give me, like they didn't label the 20-second mark on this graph, and they didn't tell me a specific velocity at that 20-second mark, that's fine, because this line is a straight line. What do I know about the gradients of straight lines? They are constant. So it doesn't matter which 2 points I use on this line. Once I have 2 points on the line, when I find the gradient would be the same for this entire line here, right? It would always be the same. So I choose 2 points on the line. Any 2 points I want to do, they actually gave me 3 points on this line, right? This one here, I have this point, and I have this point. So you choose any 2 points, and you would get the gradient. How do we find gradient of a straight line? We apply the formula. M, which is gradient, is y2 minus y1 over x2 minus x1, or the change in the y values and the change in the x values, or some people say rise and run, same thing. Let's say I wanted to use these 2 points. Doesn't matter, right? So since this value is smaller, I would say this is x1. This would be, let's just say this is y1. Actually, no, that doesn't make sense. It actually does not matter, you know. It's whatever. Let me just use this as x2 and y2, since this y value is bigger than this y value. And let me say the 28 is x1, and then the 0 is y1. So substituting these values into my formula now. M, which is my gradient or acceleration, so let me put acceleration, would be y2, which is 6, minus y1, which is 0, divided by x2, which is 10, minus x1, which is 28. I would get 6 on minus 18. And of course, this can be reduced, so I would reduce it to minus a third. Don't forget your units. This is acceleration, so meters per second squared. or ms to the minus 2. Is a concern. By the way, this is not a CSAT question. I'll tell you what type of question this is after. Everybody good with this?
Miss,
Mhm.
Miss, you would use a 20 as the x2 for when you're finding the acceleration, the gradient for that graph.
This 20 seconds.
Yes, miss.
But if you look at the graph, let me just erase all these markings. They gave me a value for 10 seconds, for 28 seconds, and for 40 seconds, and for 60 seconds. But they did not mention anything about 20 seconds. So you can't assume. So let's say, okay, I approximated the 20 seconds to be about here. They did not give me a y value or value for velocity. So I can't assume this is like a 3. I can't assume that. That's why we said we can choose any 2 points on this line. And because it's a straight line and the gradient is constant, it does not matter which 2 points I choose once it's on the line. When I find that gradient, which was minus a third, it would actually be the same for every point on this line. So this entire line, the gradient is the same, minus a third. And since 20 seconds is a part of this line, the gradient, which is acceleration, would be minus a third as well. Do you understand that?
Yes, miss.
Okay. Internet's super bad. Yeah, that's good. Is Troy still here? Troy, you good?
Yes, miss.
Okay. Please note I didn't have to use those 2 points if you actually, hold on.
Miss, you could use 6 and 40.
What you said?
Wait, yeah, not 6. Miss, I could use 10 and 40 for the x2 minus x1, like 40 minus 10. That could be used also.
I was actually going to show you that just now.
Oh, it
Then,
can be used. Okay, miss.
Yeah, I can. Since this point here, and this point, all 3 of these points on this line, I can actually use any 2 to find my gradient. So just now I used these 2 points, this one and this one, but you could actually use this point and this point. Let me spell this point. Just now I used this point and this point, but you didn't have to do that. Because all 3 of these points are on the same line, I could actually use this point and this point, or I could use this point and this point. It doesn't matter. Any 2 of these points would work. Let me just show you. Let me just use another point just to show you that it is true. Let's say I want to use, you can't really see that. Hold on. Let me use the red. Let's say I want to use this point. So at this point, the x value is 28. Okay, let me not do that. Let me use 28 as x1, and the corresponding y value is 0. So that's y1. And let's say I want to use this point here. 40 would be x2. And minus 4 is y2. Substituting my values. Y2 is minus 4. Minus, oh wait, it's still 0. So let me just do that. Minus 4 minus 0. And then 14 minus 28. So let me erase this. Right, sorry about that. So it won't be 6 or minus 18 now, right? but you should get the same answer minus a thing. -4 minus 0, that's still -4. And then 14 minus 28 is actually 12. And if you reduce -4 and 12, you would get minus a third. So it works. You can use any of these 2 points. And like you're talking about, you could use this point and you could use this point if you want to. You would get the same answer. Everybody good with this, right? We don't have to take into account
Yes,
0 to
miss.
10 seconds because they're equal to 0 in terms of acceleration. That's not what they asked me for. They asked me for the acceleration at 20 seconds. So I am concerned about this point here. Let's just assume this is 20. I am concerned what is, at 20 seconds, what is my acceleration? So what's the gradient of this line? And that's minus a third. Yeah, that's what the question asks. Calculate the acceleration at 20 seconds. They didn't say anything else. But if they did ask, let's just say they said, state the value of the acceleration between, state the value of the acceleration after the first 10 seconds, which would be this horizontal line here, then we know acceleration is 0. But that's not what the question asks. The question asks to calculate the acceleration at 20 seconds. So I want to know what is the acceleration right here. What's the gradient? Right. It's not. I'll tell you what type of question it is. Okay, so since everybody's good with that, let me clear this. Calculate the distance traveled in the first 28 seconds. So say this was your exam paper, you were in your exam, I told you the first thing to do when you see a kinematics question with a graph, just underline what type of graph they're talking about. Once you know what type of graph, go back to the key features. What are the key features of this graph that I must know? One of the key features is that the area under the graph is the distance traveled. The area under a velocity time graph is the distance traveled. So if they want me to find the distance traveled, I know that I'm finding some type of area. The problem is, what area am I trying to find? What's the shape of the thing? What's the shape? So let's see. Calculate the distance traveled first 28 seconds. First 28 seconds. So that would be, hey. Well, no, it wouldn't be like all the way down here, but it would be this under the graph. So it's really here. Like you can't see the yellow, I forgot. I mean, you could go back to the red. So first 28 seconds under the graph. That's here. That's the area they're talking about. What shape is that? Can anybody tell me what shape this is? Trapezium. Right. What are the 2 ways to find the area of a trapezium? Look at the triangle. Formula on both sides do a triangle and a rectangle. Yes. Either way is fine. So yes, the answer is 114 meters. For anyone who didn't do it yet. Trapezium. So I can use the formula, a half the sum of, so this sigma sigma notation means sum of the parallel sides by the perpendicular height. Parallel sides, I'm referring to this and to this. So 0 to 28, so this is 28. From 0 to 10, this is 10. Perpendicular height, I'm looking at this, that's 6. So this would be a half. Sum of my parallel sides, so that's 28 and 10. Multiplied by my perpendicular height, 6. Simplify this. 38 by 6, and you should get 140 meters. Remember, we don't put the unit meter squared. I know you might be tempted to because it's basically the area. Well, it is the area you're trying to find. Well, it's the area formula that you're using, but that's not what we want. We want the distance traveled. We just use the area formula of the area to get the distance traveled, right? I know it can be a little confusing at first because you know that area should be meters squared, but we're trying to find distance traveled. Distance is in meters, right?
Means aren't we going to do the one for the triangle, then add it to the 114 meters?
Yeah.
Oh, okay.
I mean, yeah, this is just the first way. If you want to use this, which is the area of the area for a trapezium, you could use this formula if you want to. If you don't want to do that, like Kitania was just saying, split it up into a rectangle and a triangle. So my triangle is this green thing here. Okay, let's just pretend that's this green shaded area is my triangle. Let me find everything I need for my triangle. Base 10 and 28. So this is 18. Height 0, 6, so that's still 6. But the area of a triangle, let me use the green to show you that this is the area for the green part. So a half by base by height, half 18 by 6 should get the same 114 meter. But oh, rejoin, I didn't even see that. Thank you. Rejoin. Let me end this. Actually, let me just wait for it. Okay, so this is 54. Then find the area of the rectangle, add the two areas. Just waiting for the meeting to end, right? 10